Thanks, Dana, and hi everybody, and welcome today. Look, I wanted to go through a little bit of a history of Protiotype, just so that everybody who maybe is not familiar with what we do and where we've come from can get a bit of perspective on that. I'm going to talk a little bit about our discovery process, some of the problem statements that we've uncovered that are of interest to our group, and then I'll talk a little bit about our labs at Singapore Polytechnic and at King Mongkut in Thailand. So Protiotype began back in 2014 at this building here, the Regenerative Design Central Mall building in Sydney, where I curated an exhibition on the topic of how technology has impacted the design process. And while I was curating that show, I got my researchers to try and investigate an area of product development, which was called smart connected products or Internet of Things products. And in those days, we found about 200 companies around the world who claimed to have an IoT product. It turned out that there were only about 10 or 12 who actually had a product, and the rest were just Kickstarter projects and prototypes and flash websites. And as I started talking to those companies and learning a little bit about how their design process was being adapted because of technology, we learned that even in those days, 2014, designers were using Skype as a design tool. So it wasn't unusual for me to find that these smart connected products were being designed by teams that might have an industrial designer sitting in Eastern Europe, a finance guy in the US, and a founder in the UK, for example. In the end, we ended up with a show with about 12, 15 companies exhibiting, and they were from the United States, the United Kingdom, India, Singapore, and Australia. We had a couple of universities involved as well. So NTU out of Singapore and University of Technology in Sydney. We tried to put as much technology as we could into this, which was a retail exhibition actually. So it happened in the shopping mall. We put in QR codes, NFC tags, Bluetooth low energy beacons to try and connect the physical presence of the exhibition with the company's online sales tools. And this was, for Protiotype, I guess a kind of almost like a de facto scientific experiment, because we were able to gather qualitative and quantitative information about the impact of technology on the space. So this slide here, you can see somebody wearing Tobii eye tracking glasses. So we're actually recording the interactions of people walking around the exhibition and so on. One other interesting project there was done by an Australian designer called Hugh Jones, who was prototyping a smart speaker. So you've got to remember, this is 2014. Back in those days, Google Home and Alexa hadn't been invented. And Hugh started to think that he wanted to have some sort of smart speaker in his house, but he didn't want to put in another technology box. He already had an Apple Wi-Fi, Apple Air, all of these other technology boxes, PlayStation. So he started to think about integrating the technological aspects into the furniture and fittings of his space. So that Protiotype exhibition created a lot of sort of debate about what is the role of technology in the built environment, in interiors, in smart spaces, and in architecture, and how might we best go about doing that. So when I got back to Singapore, a community sort of formed, and people who were interested in design and interested in science and engineering, we started giving up our weekends and getting together and playing around with cool toys. This is the discovery part, learning about HoloLens and Internet of Things and data collection and sensor-driven components. And through a series of workshops and events, starting to work up these ideas of what is a smart space, or what we call an intelligent interior. And one story I just want to relate at one of our user experience events was we had a bunch of technological tools, including some passive Wi-Fi sniffing software called Kismet. And we had a bit of a standoff between the engineers and the designers. Two groups sort of formed up, one saying, we're not going to do any work until we understand what it is the problem that we're solving. And the other part of the group saying, well, we just want to discover and learn about the technology. In the end, the engineers agreed to install the software and go about the exploratory part. And the good news was they came back after a while and said, Greg, we found a problem. And the problem that they discovered was that once they understood how to use the technology, they realized that they could dig quite deeply into the mobile phones of people who were not even logging in to the Wi-Fi router. So this is really what we got to. We've been running a lot of events, workshops, pop-ups, exhibitions, thinking about user experience, thinking about integration of technology into the built environment. Around 2017, I think, Siak Kuhn invited Protiotype to help out at Singapore Polytechnic to redesign one of their industry exhibition spaces. This is a before picture. This is partway through, and then this is what we came up with. So we helped Siak Kuhn and the School of Architecture and Built Environment to build out a smart facilities management lab and a smart sustainable building showcase. So our role was to connect with industry. So we helped bring in companies like Lumani, who brought in their smart algorithmic lighting and air conditioning control, Bosch, the IoT sensors, so we could gather 8 different kinds of environmental data from the lab space, Sony, who very generously gifted a lot of audio-visual equipment to us, and we would run tests such as, for example, this facial recognition access control for measuring and monitoring attendance of students entering classes. We also built an augmented reality training application for fire sprinkler training, which was used by staff and students. And we installed this 8-meter long mural, which is an illustration of how a smart and sustainable building might be built in best practice. Around this time, though, we started to uncover or become aware of a lot of problems with the built environment. And David, who's going to speak next, David Ivory, wrote this paper in 2016 called Solid State City, where he started to ask a lot of confronting sort of questions about the form of our cities and the form of buildings. So a couple of points that David made, that the shape of cities, the city grid is sort of determined a lot by the motor vehicle. So over the last couple of 100 years, 150 years, motor vehicles have reshaped cities. Secondly, we're able now to build very, very tall buildings because of elevators. So these new technologies from cars and elevators cause the form of the city to change. And David's question, of course, is this the right for the future? So the problems that we have isolated include things like 30% of the world's carbon emissions being produced by the built environment, 40% of the world's energy consumption, 40% of landfill coming from construction, 90% of construction projects being delivered late or over budget, and that's a really a big problem. If you think that the construction industry is a $10 trillion industry globally, the fact that 90% of projects are late or over budget is a significant economic problem. And we also noticed that in our dealings with the built environment industry that there's some kind of underlying fundamental structural problems with the continuation with waterfall project management or fast track project management, as opposed to the kind of agile software project management methodologies that people like me are familiar with in the world that we inhabit. That the built environment is building very robust, environmentally damaging infrastructure around the planet. And it's a laggard industry that's ripe for disruption. Going forward, another important thing to realize is that all of these issues coming from the built environment are compounded by population growth. And we're going through exponential population growth since the 19th century. I just want to show here this one slide, which gives an idea of the world population growth from 200 years ago, 1820, when there were a little more than 1 billion people in the world, through to today where we find ourselves at 7.5 billion, with about half of the world's population living in Asia. What's also important to understand is the rate of urbanization. So at the turn of the century, 2.87 billion people living in cities. Today, 4.38 billion. By 2050, 6.61 billion. So these are significant numbers. If we continue to build and create a built environment with sort of structural, environmentally damaging processes in place, and we add in Asia another 1 billion people, and how are we going to house them, then we're just going to amplify the problems that we've already got. So there's significant problems. One book that I can recommend people read if you've got time, written by a physicist called Geoffrey West, Scale. And one of the things that Geoffrey West points to is that the future of humanity and the long-term sustainability of the planet are inextricably linked to the fate of our cities. So this is the journey that Protiotype went on to get to the point where we're at now, having identified the problems that we want to find solutions for. So around 2017, I started to also write and present some papers to think about answering some of the questions that Dave had raised in his solid state city paper. So I gave a paper or a presentation to an A-star workshop in 2017 when I proposed that the technologies that can solve these problems are actually already here. We're just not combining them or utilizing them in the correct fashion. So I wanted to point to a couple of those technologies now. One is computation or generative design. So people will talk about, and Ian will expand upon this as well, but artificial intelligence and design. Designers over time have been adopted new technological tools. It's impacted the way we work, and I've seen that through my working career, starting out as a graphic designer with a pen and pencil and letraset, then working with CAD and so on, and now working in groups with people all over the world using Skype and Zoom and video tools. Now there's another layer with computation and generative design, and the great thing about generative design is that it allows us to use brute force computing. So I just recently bought this book called Shape Grammars, which comes from a European graphic designer, and all of these images that he's created are created with code. So he created 150,000 computer generated shapes very, very quickly. He did it much faster than he could have done that by hand, and he could create another 150,000 in minutes. So the power of generative design, of brute force AI, is a technology that designers should be aware of and utilize as a tool for solving problems going forward. The second thing I wanted to point out is advanced manufacturing. So this here is the Ford production line from about 100 years ago. And that introduction of the moving part line brought the time of production of a motor vehicle down from 12 hours to 3 hours. And now, of course, we have robotic production lines which are increasing that rate, or the efficiencies of manufacturing production exponentially. So it's about time that we brought some of these technological tools to bear to the problems that we have in the built environment. So important thing, this is a quote from Greg Cornelius here, design is about systems. So the work that we do is to make incremental improvements through our processes to improve the systems and processes of the world. Another important thing for us to understand is to step back a little bit and realize that we shouldn't so much be craftspeople now, but we should be thinking about how do we use the technological tools to design the systems to let the systems do the work, to let the computing and the robots and everybody else do the work for us. This quote, "Don't do work, design work," comes from Mike Walsh, who's an Australian management consultant. Now, finally, I just want to talk a little bit about our upcoming work in Bangkok. So I made a trip up to King Mongkut maybe 2 years ago now, 18 months to 2 years ago, to hear Professor Martin Rendell give his Beyond Bauhaus lecture. And that lecture was subtitled the Prototyping the Future, which is really resonates with what we're doing. Think back to the Bauhaus. It was 1919, it was when the Bauhaus was founded. It's an educational school. It's quite famous in the world of design. I'm not going to go too much into that. What I will just mention is that, there's a cliche around modernist design: form follows function, and we've changed that today to mean form follows function, being a reusable block of code. I'm not going to expand on this point, and we leave it for another day. Fair to say that it's also the view of Protiotype that modernism is incongruous with our time in history, and we need to find new paradigms. So in Bangkok, we went back there in February and had our first prototype event there, Design Future Build. The future is green. And we had this event at the beautiful Samyan Midtown building in Bangkok. There was a good panel discussion happened with Dana was the moderator, and Tika, who was on the plenary this morning, Ian, who's going to speak shortly, and Mark, who will speak shortly. Also brought in some industry partners and some new toys to play with. And we announced that we would be launching the Prototype Architecture Lab, PAL, in Bangkok, which we've just done last week. So the signing ceremony, there's Assistant Professor Dr. Antika and Dana and other stakeholders having their signing ceremony. Again, we managed to bring in some industry partners such as LG, who have generously loaned us some fantastic audio-visual equipment, and a bunch of other companies from CommScope and IES. What we're really excited to do, though, is hopefully once the pandemic settles down or goes away, we hope to be able to utilise the fantastic workshops that exist in the Faculty of Architecture and Design that will allow us to do woodworking, metalworking, and plastic fabrication. And we start to think about our solving these big problems that exist. So the PAL Research and Design project will essentially be a system design. And we think about the generative design of modular, and that will be David's topic next, modular systems, interchangeable part, mass customizable structures made from sustainable materials and embedded with IT for prefabrication by advanced manufacturing facilities. And the reasons for us to do that is because design is about systems, and we don't want to do work, we want to design work. That is it from me. I just wanted to add one last thing. For those who might be thinking, how can we reach out to these guys today? You can just go to our website, protiotype.com, and there's a newsletter sign up feature there. Or please follow us on LinkedIn, which is the social media that we're most active on. Thank you.
Greg, thank you so much. And everyone, I will put these links in the chat as well. Again, if you do have questions, the chat is where you can ask them. Greg, you brought up a ton of great topics. And before I asked David to come in and discuss modularity with us, I wanted to ask you to go back to that time you talked about having sort of a standoff between engineers and designers. And as someone who was an engineer and has sort of transitioned into more of a design role in my own life, I understand the two mindsets and how they often can compete. But there's also an opportunity there to really collaborate and push the idea that you brought up about systems and designing work forward. Could you talk about that a bit more and where you see the opportunities there between engineering and design?
Yeah, sure. So it's true that Protiotype, because we've had an interest in technology, we find that engineers and scientists are sort of naturally attracted to what we do. But it's important to balance that out with a design thinking, for want of a better phrase. And what designers tend to do, and this is for all designers, architects, user experience designers, graphic designers, industrial designers, we naturally want to put the human at the center of what we do. People are the focus for design work. So in bringing that way of thinking to the process with the engineers and scientists We just want to nudge our projects into the right direction so that the human experience, so that people always stay at the center of our thinking. And that will be the same with our systems thinking, which I think David might even talk to that a little bit. But the systems themselves should be supportive of what we want to do as human beings.
Fantastic. Thank you so much, Greg. Great presentation.